Dr. DeBacker, in addition to providing better care to patients, how does FRI help physicians and medical facilities?
Exactly. So, as I said before, with the conventional lung function tests, you're kind of flying blind a little bit. So, as a treating physician, it's hard to know what's really going on. So, you're pretty much chasing the facts. A lot of trial and error in terms of which treatment might or might not work. So, if you have a more accurate description of the current disease stage, it's easier for the physician to prescribe the most optimal therapy for the individual patient. At the same time, we're also working with pharma companies and medical device companies to develop these drugs using FRI parameters, such that it becomes even more easy for the physician to match the right patient with the right treatment over time.
Can you please explain how Fluidda improves the efficacy of clinical trials?
So, again, the primary endpoint in a clinical trial is that spirometry endpoint, so forceful exhalation into a machine. And the fact that it's not very sensitive means you have to study a lot of people over a long period of time. Now, what FRI actually does is we're opening up the black box and we're really looking at the regionality in the lung to see how healthy or diseased it is. And by taking a scan at baseline and after the treatment, we can really see what this potential drug does in a much smaller population and in a much shorter period of time. So you really accelerate drug development and you're going to make, let's say, the right drug for the right patient. And that's what we're trying to do with FRI in clinical trials.
And what types of diseases can FRI help?
So we very much focus on respiratory. But within respiratory, we look at everything like asthma, COPD, lung fibrosis, cystic fibrosis that affects mainly younger people, pulmonary hypertension, and also now these respiratory infections that seem to be causing a lot of problems these days.
And why is FRI better than previous methodologies?
Exactly. So the spirometry doesn't really give you that regional information. And since the lung very much compensates for disease, you can have a lot of disease already in the lungs, which is undetected by the conventional way of looking at lung function. So by opening up the black box, by really focusing on the different regions, we can very much assess the true disease state of the lung and then intervene earlier. Because one of the hallmarks of lung diseases is that apart from infections, they're typically not reversible. If you have COPD, if you have asthma, if you have lung fibrosis, you tend to lose lung function over time. The only thing the drugs do is slow down the progression. That also means the lung function that you have lost, you will never regain. So that's why it's so important to catch it early on so that we can keep these patients healthy as long as possible.
Dr. DeBacker, how does FRI help with physicians with early detection?
So the nature of the lung is to compensate. So if you're just looking at symptoms, if you're just looking at spirometry, they will remain normal for a long period of time, even though the disease is already proliferating. I just read an article about the coronavirus on one of these cruise ships, where they actually looked at CT scans, so they looked at images. And even with a visual read of the scan, you can already detect the virus in patients with no symptoms. So one of the issues with the spread is that you can spread the virus without showing symptoms. But we are quite convinced that if you look at a CT scan with a sensitive technology like FRI, you can already detect the disease and you can already detect how much this lung is compensating for this disease. So that makes it a predictive tool to determine what will happen to these patients over a longer period of time. And again, the sooner we can intervene, the sooner we can avoid any ICU admissions, etc.
And I understand that FRI has a predictive component. Can you tell us about that?
Exactly. So if you can get to the true disease state of the lung, almost by default it becomes predictive. Because first the lung on a regional level becomes diseased, then that spreads. At one point in time, the patient starts to show symptoms. Afterwards, the patient starts to decline in their conventional lung function tests, so the spirometry. So if you can describe the disease more accurately in the beginning, you can almost tell what is going to happen over a longer period of time if you don't do anything. But if you intervene at that point in time, you do have a chance to reverse the course of a potential decline in lung function, a potential decline in lung health.